This video is the 6th installment in a short series on antiderivatives and indefinite integrals, and this time we're just quickly deriving the indefinite integrals for tangent and cotangent. The strategy for both of these integrals is just to set up the integrand in terms of the sine and cosine functions, and then we're going to look for the chain rule operating backwards. Starting with the tangent integral, the tangent function is sine over cosine, so we have the integral of sine x over cosine x dx. Now what I recognize in this is that the derivative of the denominator is sitting right there in the numerator. All we have to do is make a minor adjustment because the derivative of the cosine function is negative sine, and then we'll compensate with a minus sign out in front of the entire integral. And anytime you have the derivative of the denominator sitting in the numerator, this is the result of the chain rule operating on the natural log of the denominator. And we'll verify that with the derivative at the end, but for now, we get deeper into the answer. I have negative natural log absolute value of cosine x plus c. So the key to getting comfortable with just casually using the chain rule backwards is that you're always at least mentally checking your work by using the derivative. And so that work would look something like this. I want to take the derivative of what I'm claiming here is the antiderivative. And I'm not going to worry about the absolute value for this verification. And when I take this derivative, well, I have a natural log of the cosine. So I get 1 over the argument of the natural log function. And there's a minus sign that's a spectator here. So 1 over the argument of the natural log function, which was a cosine. And then the chain rule says I have to multiply by the derivative of the cosine function, which is negative sine x. And of course, I'm ignoring the plus c because the derivative of that is 0. The minus signs cancel. I get sine x over cosine x, which is tangent x. And I can see that this chain rule backwards approach works out. Now there's a more popular way of writing the result of this integral. And what we do is we use log properties on it. And I take that minus sign out in front of my natural log function and I move that up as an exponent of -1 on the argument of the log function. So now I have natural log absolute value cosine x to the -1 plus c. But what's cosine x to the -1? That's 1 over cosine x, and that's the secant function. So this is probably the most common way to see the answer for the integral of tangent x. It's the natural log absolute value of secant x plus c, and we're done with that one. So the cotangent integral is similar. In some ways, it's actually easier. The cotangent is cosine over sine, and this time there's no adjustment for a minus sign. The derivative of the denominator is just sitting right there in the numerator. So I know this comes from the natural log absolute value sine x plus c. It's probably more common to see this expressed in terms of a cosecant. So what we do is we put a minus sign in front of the natural log and an exponent of -1 on the argument of the log function. This is legal because using properties of logs, I could take that -1 in the exponent and move it out in front, and I would get what I started with. And 1 over sine is cosecant, so I get negative natural log absolute value cosecant x plus c, and we're done with that one. Now, it would be wise to go ahead and check using the derivative, just like I did in the first one, but I'll leave that verification up to you. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.